Okay, so this video is on solving log and exponential equations. This is going to be the first of 4 videos on this exact same topic. That should sort of tip you off that it's an important topic, and there's kind of a lot of little things to it. So today, if you'll notice on this title slide, it says no calculator. That doesn't mean you can't use a calculator. It means that your answers are going to be exact. It means that you won't be getting like weird decimal answers from your calculator that you will later in the week. All right, so you'll kind of get a sense of what that means as we move along. Okay, so here are some helpful tips. If the bases are equal, which you've seen before, if the bases are equal, then either the exponents or the arguments are also going to be equal. Okay, what that means is that sometimes you'll be working in log form and sometimes you'll be in exponential form, but if you can find bases that are the same, sometimes that'll help. All right, and then when, not if, but when you're stuck, all right, and you've heard me say this before and you're gonna hear me say it a lot, try switching from one form to the other. Okay, so let's move this up and let's actually just get started. All right, so this problem is cut and pasted straight out of the book. We are trying to solve for x. So what I'm going to do, and yes, I am going to use a calculator. I'm going to see if 3 to some power is equal to 243. And when I use my calculator, I figure out that 3 to the 5th is equal to 243. So all I did here is I rewrote my equation where I wrote the right-hand side in the same base. Because now that the bases are equal, these exponents have to be equal. So x equals 5. Okay, again, let's try another one. Okay, so I guess the question is, can I write this side in base 7, right? Because if I can get the bases to be the same, then all I have to worry about is the exponents. All right, so I know that 49 is 7 squared, but because it's in the denominator, I'm going to write that as 7 to the negative 2. All right, and again, yes, you can use a calculator, just don't use it to solve, right? You can use it to check about exponents, though, and if you type in 7 to the negative 2, you will get 1 over 49. So now that these bases are equal, that means that these exponents have to be equal. All right, so x equals negative 2. All right, moving up. Okay, now this example, this is a great example. I really like this one because we're going to change both of them. Okay, so on the previous 2 examples, I only had to change one side of the equation. But on this one, I'm going to change both of these because I can write them both in base 2. So on the left, this is 2 to the negative 1. And 32 is 2 to the 5th. Okay, now if you remember the rules, raising an exponent to another exponent, you multiply those exponents together. All right, and then just like on the previous 2 examples, if the bases are equal, then those exponents have to be equal. And you can solve that equation very easily. X should equal negative 5. All right, scooting it up. Okay, so let's see. Maybe I can write, and this may take some like trial and error. Okay, I'm guessing that this number over here on the right, I can write as base 3/4. All right, I'm hoping that's true. I'm not sure if it's true, but let's see. I think 3 to the 3rd is 27, so the question then is 4 to the 3rd 64? And it is. All right, so again, you can use a calculator to check that part. Once you've got the bases equal, the exponents have to be equal. All right, again, let's try another. Example 5. Okay, so this one is slightly different in that there's sort of a random 5 hanging out in front. So what I'm going to do is I'm going to divide both sides by 5. So if I divide both sides by 5, I end up with getting 8 to the x equal to 65. Now, if that was 64, this would have been a fantastic problem where I could get the bases the same. But I can't, right? 65, I cannot write that in base 8, right? Or in any other base, right? It's 5 times, what, 13? Yeah, it doesn't come out to be anything else. So if I'm trying to solve this thing for x, this is one of those situations where I'm like, holy crap, I'm stuck. So I'm going to change it from one form to the other. Right now, this is in exponential form. So I'm going to rewrite it in logarithmic form. All right, in logarithmic form, let's see, it's log base answer equals exponent. Okay, so I know that this is in calculator ready form, right? If I, again, on a lesson where you're allowed to use your calculator, I would keep going. But this particular lesson, we said no calculator, this is the answer. All right, so let's try something like this. All right, and again, I'm hoping that I can get these to be the same base, but we'll see. 81 is 3 to the 4th, but it's in the denominator. So let me rewrite this. This is going to be 3 to the x minus 1 equals 3 to the negative 4. All right, again, if you can get the bases to be equal, that's amazing. And if you do so, then the exponents have to be equal. And adding 1 to both sides gives me negative 3. Ooh, interesting. Okay, so I'm trying to solve for x. This is kind of an interesting example because we haven't seen one like this, but that's okay. I am going to move this entire term to that side by adding. And once I do it, you're going to be like, oh, that makes total sense. Natural log of x is then going to equal the natural log of 2, right? Do I have equal bases? And I do, right? This is natural log, which is base e. This is also natural log, which is base e, which means in this case, these arguments will be equal to each other. This is x equals 2. All right, let's move to this one. Okay, ooh. All right, again, sort of weird. This time I only have a single natural log, so I can't move things to the other side or anything. Again, when you get stuck, switch it to the other form. There is an invisible base right here, right? It is base e. So if I write this in exponential form, it's going to be the base raised to the power, right? So it's base answer exponent, base answer exponent. Now I know what x equals. It equals e to the negative 1. Okay, and again, we're not using a calculator. I don't really know what number that is, and that's totally okay. We are not using a calculator to get these to be decimals today. All right, now this one you may be able to look at it and know what the answer is, and if you can, great, knock yourself out. All right, but if you can't, this is another one of those situations where if you get stuck, you write it in the other form, because that's the base, that's the answer, and that's the exponent. So this is x squared equals 25. Ooh, that means, check this out. 25 is 5 squared. This is one of those situations where the exponents are equal, which means then that the bases must be equal. X has to equal 5. All right, let's give this one a try. This might be my last one, not sure. I'm going to approach this like I did the last one. I am going to take it out of log form and put it into exponential form. So the base is 10, the exponent is negative 1/2, equal to the answer. I might simplify this just a little further because of the negative exponent. Maybe just a little. I know I didn't on the one with the e, but I don't know, I'm going to on this one. Because that ends up in the denominator. Ooh, in fact, I probably should rationalize that. Right, so let me just keep going. I'm going to move it over here. Because this is 1 over the square root of 10. And we're not allowed to have radicals in the denominator, so I'm going to rationalize. So I'm going to multiply the top and the bottom by rad 10 over rad 10, giving me an answer of rad 10 over 10, right? Those come out from under the radical. Now this is a legal answer. Okay. Let's see, so I can't do anything right now, right? There's no way to change the base here. So I'm going to take it out of log form since I know there's a base e right there. It's going to be e to the 8th is equal to 3x plus 5. All right, now you know how to solve an equation. You know how to get x by itself. We're going to subtract 5 from both sides. And then we're going to divide both sides by 3. So I should have an answer, grand finale here, e to the 8th minus 5 over 3. All right, let me know if you have any questions. Happy to help.